Assalamu alaikum. How are you, students? Hope you all are fine. So we should have a great morning. Dear students of Standard 11, welcome back to my physics class. Dear students, today I am here to explain an interesting topic, that is entropy. Yet I didn't start second law of thermodynamics, but for understanding second law of thermodynamics, entropy is the most important thing, and entropy is the most important thing in the chapter thermodynamics. That's why today I will start entropy. If you understand entropy, then second law of thermodynamics will be easier to you. Dear students, I will show you some pictures. Look here, the books are arranged, and here the books are not arranged, disorderliness. So here the books are arranged and I can tell entropy is less, and here the books are disarranged, so entropy is more. Again, I will show you two more pictures. Here you are seeing an arranged classroom, and here are disarranged classroom. Look, here all the students are gossiping with each other. So, and the teacher also will lose her attention if she takes class in this situation. So chaos will be created and disorderliness will be occurred here. So we can tell entropy is more here. So by showing these four pictures, I told you here is entropy is less and here is entropy is more. So it will be, the question will arise to you. That means entropy will be related to what? Entropy is related to disorderliness. That's why I have shown you these four pictures where I have shown orderliness and disorderliness. So the more orderliness of an object, the less entropy will be there, and the more disorderliness of any object, the more entropy will be there. So entropy is related to disorderliness. So we can tell entropy is the index of disturbance or chaos in any system. So the index of disturbance or chaos in any system is measured by a quantity which is called entropy. That means entropy is a measure of disorderliness or randomness. So let's try to learn the definition of entropy. Thermodynamic quantity representing the unavailability of a system's thermal energy for conversion into mechanical work, often interpreted as the degree of disorder or randomness in the system. The second law of thermodynamics says that entropy always increases with time. Look, here the particles are very nicely arranged. That means they are close to each other and closely packed, closely bound to the system. So here highly ordered and low entropy. Here high disordered and high entropy. Because you know entropy is related to orderliness. The more disordered, the more entropy, and the less disordered, the less entropy. So entropy of the solid will be least and entropy of the gaseous substance will be more. Look, here one solid substance is shown whose particles, whose molecules are very closely packed and arranged, and when heat is given to the solid, then it will turn into liquid. The intermolecular, they will overcome their intermolecular force, so the intermolecular distance between them will be increased and the molecules will be disordered. So entropy will be more than that of the solid in liquid, and it will be highest in case of gaseous substance where we can see the molecules are at far distance from each other. That means their intermolecular distance will be increasing. So here disorderliness is occurring and entropy will be highest as a result. Entropy is indicated by the symbol S. So S solid is less than S liquid is less than S gas. Now, significance of entropy. Entropy is a physical quantity. It is equal to the ratio of heat absorbed or rejected to the temperature. It is a thermal property of a body which indicates the direction of flow of heat. It is a spontaneous process. Spontaneous process means the process which is occurring without any pressure. The orderliness of an object decreases with the increase of entropy. Like temperature or pressure, it cannot be felt. So this significance can come as your B number question. You must memorize this. As a system goes towards equilibrium, the possibility of getting work from the system reduces, and when it attains the equilibrium, no work is found from it. So this disability of converting the energy is known as entropy. When the entropy of the universe will reach at the highest point, then everything will attain the same temperature. As a result, heat energy will not be possible to convert into mechanical energy. This state of the universe is so called heat death of the universe. And when heat death of the universe will come, that time this type of situation will occur. That means the iceberg in the Antarctica will melt. So entropy is a physical quantity. I have told you. Entropy cannot be measured directly like heat. We cannot measure heat, but we can measure the change of heat. Similarly, we cannot measure entropy. We can measure the change of entropy. Because I have told you entropy is related to disorderliness. Suppose a boy is very naughty. So how much naughty he is cannot be measured, but his change of naughtiness can be measured. That means how much more naughty he becomes today than yesterday, that can be measured, because disorderliness or randomness, these are not regular quantity, so those cannot be measured, but their change can be measured. Like your happiness, your sorrowness cannot be measured. So entropy cannot be measured, but the change of entropy can be measured. Entropy is measured by the rate of change of heat absorbed or rejected with respect to temperature of the system. Suppose a system absorbs or rejects dq amount of heat at absolute temperature T. So S change of entropy. S is change of entropy. Then ds equal to dq by T. That means ds is the change of entropy equal to change of heat absorbed or rejected to the absolute temperature. And its unit will be what? Joule per Kelvin, because the unit of heat is joule and the unit of absolute temperature is Kelvin. So the unit of entropy will be Joule per Kelvin. So entropy is the physical property of the body that remains constant in adiabatic process. In adiabatic process, entropy is constant because in adiabatic process, there is no exchange of heat, so the entropy will be zero. Change of entropy will be zero in adiabatic process. So if this type of MCQ comes in the examination, in which system entropy is zero? Option A isothermal, option B isobaric, option C isochoric, and option D adiabatic. Obviously the answer will be D, adiabatic, because in adiabatic system there is no exchange of heat. As a result, change of entropy will be zero. So it is also called the thermal inertia, which is the measurable quantity. Thermal inertia. Inertia is the state of anything to remain in a state of rest or of motion. So thermal inertia, that means when heat will not be converted into mechanical energy. So entropy is also called as thermal inertia, because if entropy is increased, then heat cannot be converted into mechanical energy. So how much change of entropy of a system takes place can be determined that I have told you. So for entropy, change of entropy measurement, we need heat absorption or rejection to the absolute temperature. So heat absorption or rejection can be occurred in two steps, that is change of temperature, in case of change of temperature, and in case of change of state. You know, when temperature is changed, that time heat can be absorbed or rejected, and when state is changed but the temperature remains constant, that time also heat can be absorbed or rejected. So in case of change of temperature, the heat that is absorbed or rejected can be measured by using this formula, and you have learned it in class 9-10 level. That is dq equal to, that time you have learned del q equal to, or q equal to ms del theta, isn't it? Can you remember? Q equal to ms del theta, but in HSC level it will be dq equal to ms dt, where m mass of the object, S is the specific heat, and dt means change of temperature, that means final temperature minus initial temperature. Now change of state, dq equal to mlf or dq equal to mlv, that means mass into latent heat of fusion and mass into latent heat of vaporization. So from here, q equal to required heat to change the temperature or state, m is the mass of the object whose temperature or state is to be changed, Tf is the final temperature, Ti is the initial temperature, Lf is the specific latent heat of fusion, Lv is the specific latent heat of vaporization. Again, I am showing that chart that I have shown in the previous slide. So the amount of heat when change of temperature, that this temperature is changed, that means can be measured by this formula, and the amount of heat absorbed or rejected can be measured by this formula. When state is changed but the temperature is not changed, temperature remains constant. So when temperature is changed, that time the change of entropy ds can be measured by using this formula, ds equal to ms ln tf by ti, and when state is changed but the temperature remains constant, that time the change of entropy Ts can be measured by this formula, mLf by Tis equal to mLv by T stream. Here Tis is the ice point or melting point, and that means lower fixed point. And here mLv, m is the mass, Lv is the latent heat of vaporization, and T stream is the steam point or boiling point or upper fixed point. Dear students, in an irreversible process, the change of entropy is positive. Irreversible process means what? The process which is not reversed back to the initial state, that is known as irreversible process. So in an irreversible process, the change of entropy is positive. And you have to remember one thing, every irreversible process is spontaneous. And in every spontaneous process, heat flows from the higher temperature body to the lower temperature body. So let two objects completely isolated from the environment are kept in thermal contact with each other. The temperature of the first object is T1, which is at higher temperature, and the temperature of the second object is T2, which is at lower temperature, and they are kept in thermal contact, so heat can be exchanged with them. And the temperature T1 is greater than T2. Here T1 is greater than T2, then heat will flow from the warm object to the cold object. So let within a very short period of time, dq amount of heat is transferred from the warm object to the cold object. That is, the warm object will lose dq amount heat and the cold object will gain dq amount of heat. So the object which lost heat, entropy will be decreased for that object, and the object which will gain heat, the entropy will be increased for that object. So here the first object, that means the warm object, will lose heat. So here the decrease of entropy of the first object will be minus dq by T1. Here dq equal to amount of heat which is rejected, and T1 is the absolute temperature of the first object. Here I have used minus sign because minus indicates the decrease of entropy, and the increase in entropy of the second object will be plus dq by T2. Here plus sign is used because of increase of entropy of the second object. So the change of entropy will be what? ds equal to minus dq by T1 plus dq by T2. So dq by T2 minus dq by T1. Dear students, I have told you T1 is greater than T2. So 1 by T2 will be greater than 1 by T1. We have to remember one thing. If one object is greater than another object, then their reverse thing will be opposite. That means 1 by T1 will be less than 1 by T2. Its inverse will be opposite. Okay. If one object will be greater than another object, then their inverse will be opposite. So 1 by T2 will be greater than 1 by T1. That means ds is positive. Del S is positive. So the change of entropy is positive in an irreversible process, and also you can tell in a spontaneous process. And every irreversible process is spontaneous, and in every spontaneous process, heat always flows from high temperature body to the low temperature body. And a spontaneous process is that process which occurs without any pressure. That means in a spontaneous process, disorderliness or randomness occur. Now I will show you some mathematical problem. Calculate the change of entropy in order to change the temperature of 5 kg water from 10 degrees Celsius to 100 degrees Celsius. So in this math, you can see the temperature is changed. The initial temperature is 10 degree and the final temperature is 100 degree. And here you have to find out the change of entropy. I have already told you the entropy is a physical quantity which cannot be measured, but its change of entropy, but the change of entropy can be measured. Okay, because entropy is the measure of disorderliness. That's why disorderliness, how can you measure disorderliness? But you can measure the change of disorderliness. So Ti equal to 10 degrees Celsius, that can be written in Kelvin scale, 283 Kelvin. Tf equal to 100 degrees Celsius, that is 373 Kelvin. And for doing this math, we need this formula, ds equal to ms ln Tf by Ti. Okay, mass is what? 5 kg. Okay, change of entropy ds equal to what? We have to find out that. And here specific heat of water, you know, the specific heat of water is what? 4.2 into 10 to the power 3 joule per kg per Kelvin. It is a memorized term for you from class 9th level. You got it, so I think you remember. Now you put the value in this equation. Mass is 5, then is specific heat equal to 4.2 into 10 to the power 3, and ln 373 by, you know, ln Tf by Ti equal to what? Ln Tf minus Ti, isn't it? Ln Ti. So it becomes 5.79 into 10 to the power 3 joule per Kelvin. Very easy math. isn't it? Now I will show you another one. Determine the change of entropy in order to convert 10 kg of ice at minus 5 degrees Celsius to water at 60 degrees Celsius. So here three steps. In 3 steps we have to do this math. At first, minus 5 degree ice to 0 degree ice. Then 0 degree ice to 0 degree water. Then 0 degree water to 60 degree water. So in these 3 cases we have to measure the change of entropy, and then adding all those and change of entropy we can get the total entropy. That means from minus 5 degree to 60 degree Celsius. So look here, m equal to 10 kg and initial temperature Ti equal to minus 5 degree Celsius, but minus 5 degree equal to 268 Kelvin, and Tf equal to what? 0 degree Celsius, 0 degree equal to what? 273 Kelvin. Okay, and specific heat of ice is given, that is 2100. Okay, so here temperature is changed, that means here the amount of heat can be measured by msdt. So here when temperature is changed, that time the change of entropy is measured by this formula, ds1 equal to ms ln tf by ti. But here temperature remains constant, 0 degree ice to 0 degree water, temperature is same, but the state of the object is changed, that means ice to water. Okay, so here ds will be, and here latent heat of fusion will be taken because ice to water, that's why latent heat of fusion. So mlf by t ice. Look here, 60 degree water to 0 degree water to 60 degree water. Okay, so here the state is same, water, but temperature is changed. So again here ds equal to ms ln tf by ti. So in these 3 cases we can find out the change of entropy separately, and then adding all them we can measure the total entropy. This is your homework, and this, I have given you the procedure. How can you do the math? You will solve it in your copy. So dear students, I think entropy is clear to you. If anything is unclear, or if you don't understand anything, you can message to me. Goodbye everybody.